Hello everyone. In this video, I'm going to define what a Cartesian coordinate plane is. Then I will talk about the symmetry of points as well as the midpoint formula and the distance formula. So what is a Cartesian plane? It is simply defined by two perpendicular real number lines, which we call axes. One of the lines is horizontal and we call it the x-axis. The other line is vertical and we call it the y-axis. Now we use these axes to describe any point in the plane. For example, if we have any point in the plane, we describe it by the following ordered pair, which contains two numbers. The first number is labeled by x and the other is labeled by y. X is called the abscissa of the point and y is called the ordinate of the point, and the whole pair represents the coordinates of the point. Moreover, these lines divide the plane into four regions. That's the first region or the first quadrant. So we call this quadrant 1. This region is called quadrant 2. This is quadrant 3. And finally, this is quadrant 4. In quadrant 1, all the points have a positive abscissa as well as a positive ordinate. In the second quadrant, the abscissa is negative and the ordinate is positive. In quadrant 3, both the abscissa and the ordinate are negative. And in the fourth quadrant, x is positive but y is negative. Let us now talk about the symmetry of points. The first case is the symmetry about the x-axis. If we have 2 points which are symmetric with respect to the x-axis, as this figure, so if the first point has coordinates xy, so the second point will have coordinates x, so we have the same x, but negative y. So whenever we have a symmetry about the x-axis, then the x's will be the same, but the y's will be the opposite. And this is an example. A and B are symmetric with respect to the x-axis. As you can see, both points have the same x, but y's are opposite. In the case of the symmetry about the y-axis, we have the same y, but opposite x. And this is an example. C and D are symmetric with respect to the y-axis. They both have the same y, which is -2. However, x of C is -4, and x of D is the opposite of x of C, which is 4. The third case is the symmetry about the origin. In this case, both x and y are opposite. And the origin, which is the point of intersection of the two axes, is the midpoint. So whenever we have symmetry about the origin, we will always end up having the origin as the midpoint. The fourth case I will discuss regarding symmetry is the symmetry about the line of equation y equal x. And by the way, we call this line the first bisector. In this case, if the first point has coordinates xy, then the second point will have coordinates yx. So we interchange the x and y. And if we join these 2 points, we'll end up with a line which is perpendicular to the line y equal to x. And we use this symmetry when we sketch the curve of the inverse function, as you will see in later videos. The next topic is the midpoint formula. In other words, it is a formula which gives us the coordinates of the midpoint of a segment. If I have a segment AB and M happens to be the midpoint of this segment, then x of M is equal to x of A, which is x1, plus x of B, which is x2 divided by 2, and y of M is similarly ya, which is y1, plus yb, which is y2 over 2. So it is like we are finding the average of the abscissas and the average of the ordinates. Let us do a quick example. If we have A, let's say 3 and -2, and B is 1 and 5, then the coordinates of M are x of A plus x of B over 2 and y of A plus y of B over 2. Thus, M has coordinates 2 and 3 over 2. The final topic in this video is the distance formula. In other words, how to calculate the distance between 2 points, or the length of a segment given its endpoints. Let's derive the formula. To do that, we draw a horizontal line passing through A and another vertical line passing through B. Now, what are the coordinates of the point of intersection of these two lines? The abscissa of this point is similar to the abscissa of B, so it is x2, and the ordinate of this point is similar to that of A, which is y1. Let us now find the length of this side. The length of this side is simply y2 minus y1. Similarly, the length of the other side is x2 minus x1. Of course, these two lines are perpendicular, which means we obtain a right triangle. Thus, we can apply the Pythagorean theorem. So the Pythagorean theorem tells us the hypotenuse squared, which is AB squared, is equal to the length of the first leg squared. So that is x2 minus x1 squared, plus the length of the other leg squared. So it is y2 minus y1 squared. In order to find the length of AB, we apply the square roots on both sides. Thus, AB equals to the square root of x2 minus x1 to the power of 2 plus y2 minus y1 to the power of 2. And we've got the distance formula. Let's do a quick example. So we have A3 negative 1 and B negative 2, 4. We assume that this is x1, this is y1, this is x2, and this is y2. Thus, the length of AB, or the distance between the points A and B, is the square root of x2 minus x1 to the power of 2 plus y2 minus y1, so it's negative minus 1 to the power of 2. Minus 2 minus 3 is negative 5, so negative 5 to the power of 2 plus 4 minus minus 1, that is 4 plus 1, which is 5 to the power of 2, equals to 25 plus 25. That is the square root of 50, but 50 is 5 squared times 2. Thus, the final answer is 5 times the square root of 2. A final remark regarding the distance formula. Since we have square on x2 minus x1 and y2 minus y1, we can also say that AB is equal to the square root of x1 minus x2 to the power of 2 plus y1 minus y2 to the power of 2. So this is not going to affect the answer because of the square. For example, if we have 1 minus 5 squared and 5 minus 1 squared, the first one gives us negative 4 to the power of 2, so that is 16. And the second one gives us 4 squared, which is equal to 16. So both answers match. The next video will be the final video in the prerequisites in college algebra, and I'll explain the equation of the circle in that video.